Hello, in this video I will show you how to demolish mesh objects. So we will cover all these mesh demolition properties here. First I want to start with this demolition type properties because this is where you can define how mesh object will be demolished, when it will be demolished. So first property here is runtime, and runtime means that the object will be demolished in runtime when it will collide with something. So when you start play mode, nothing happens yet. You initialize object, and when object collides with some ground or with some other object, this is when fragmentation happens. This is when its mesh goes through all these fragmentation slices and go into fragmentation libraries, and then it turns these fragment meshes. Then it creates fragments, fragment game objects, and apply these meshes. And in this case, I'm using this awake precache fragmentation type, and it means that all fragment meshes will be created in awake when object will be initialized. Right now you see rigid component is not initialized yet. So when I click initialize, I'll hit pause so it won't fall. So here you can see it says fragment mesh is precached. So it already created all the fragment meshes. There are no game objects with fragment meshes yet, but fragment meshes already generated and stored inside rigid component. So when object will fall, it will only need to create game object with mesh filter and mesh render and apply this fragment meshes. And obviously in this case it won't spend resources at the frame when it collides to create its meshes. It only have to create game objects. And in this third example, you can see I set it to awake prefragment. Again, I will close, click initialize. Now you see it says here fragments created, 14 fragments already created. So right now all these fragments already created, and they are stored in Rayfire main. You can go there, go to the storage fragment. Here you can see, so these are the fragments, all the fragments which are already in your scene. This is where they stored in a Rayfire manager. And here you can see the fragments from the runtime fragmentation demolition type, this one from precache demolition type, and here are prefragmented fragments for this rock prefragment object type. As you can see, they are deactivated right now. So when it collides, they simply activates and replace original object. So this is the fastest runtime demolition type because it's the most resourceful operations already done in Awake. They basically just only need to activate all these fragments. And the last fragmentation type here is reference demolition type. Reference demolition type uses this special reference demolition properties, and there will be another video about all these properties here. Right now I'll just quickly show you how it works. So all you need to do in this case, and this is actually the fastest demolition type you can get without using libraries. With reference demolition type, you can use, it means that you can use this demolition type on any platform without any platform limitation, because all the fragments you create in editor. So all you need to do is just apply Rayfire Shatter component. Again, this is just a quick overview how it should be used to create a Rayfire Shatter. You click on fragment, get this set of fragments here. So here are my fragments I created right now. Then you just need to, now you can basically delete Rayfire Shatter. Then you go to Rayfire Rigid and you define here this reference here. So you can deactivate it. Oh, not this one. You can deactivate these references. And that's it. Now you can initialize. And when the subject will fall, it will be replaced by instance of the fragments you just created. So here you can see, no, these fragments are still here because I used instantiation in this where you can define, but you can use the same fragments which you already have in your scene. So this is how reference demolition works. It just uses predefined references which you already created and you store somewhere. You can use prefabs, and I will talk about this reference demolition in another video, especially for reference demolition. But this is for demolition types which you can use for mesh demolition. So the first property here is amount, and this value defines amount of points in Voronoi point cloud. These points will be generated in bounding box of the object. So it will not use actual mesh, but it will use this bounding box kind of shape. And obviously, the more fragments you will generate, the more fragments will be outside of the actual mesh. Even though point may be outside of the mesh, it still may generate fragment. But if it will be too far, then it will not generate fragment. You probably will get less fragments than you set here. Just keep this in mind. So in this case, I have set it to 15, and you can see it created only 40 fragments. But for this object, I set it to 90. And as you can see, this time it created only 65 fragments. So this is something you should keep in mind, that depends on the shape of your mesh. The more fragments you try to generate, the more points will be outside of the actual mesh, and the less fragments you will get. If you want to have 90 fragments, then you should probably set something like 140. And then in this case, it will create something at around 100 fragments. So just keep in mind, the more fragments you want to get, the more points you need to generate. But again, this depends on the mesh shape. And the second property here is variation, and it works in percentage relative to amount property. And in this case, I set it to 0, which means I will generate 10 points, and it will create 10 fragments. But this time I set it to 100, and it works in percentage. So it will generate 10 plus 100% from the 10, which means another 10. So it means that it will generate points in a range from 10 to 20. Every time this variation will be random. So in case you have some prefab and you are going to demolish it a lot of times, every time you instantiate and demolish it, you can set variation to 100, and every time you'll get random amount of fragments. So it will not be the same every time. Next property here is contact bias, and it allows you to create more tiny fragments around collision point. So here I have my 3 objects. Here for this one I set it to 0. For second one it's 0.5, and for this one it's at maximum at 1. Let's take a look at fragments. Here you can see this one creates this relative uniform fragments. All of them have pretty the same size. You can't tell where exactly collision happened when this object was demolished. But for this one, here you can see it creates more tiny fragments around collision. And with value 1, it creates even less fragments here. You can see there are very small fragments. So this is why it's maximum. You should probably use something at 0.5 or 0.7. That object was demolished where it collided. So this property, contact bias property, works only with runtime demolition type, because awake precache and awake prefragment creates fragments in awake, and there is no any collision information in awake, and the reference demolition uses already prefragmented versions. So this is the only demolition type that allows you to use contact bias property. And this is a way for player in your game to actually understand that he's in charge of how and where to demolish object. Because in this case, player may think that you already have some kind of prefragmented version, like with reference demolition, and only with using contact bias, player will see that object demolishes depends on the collision, so he can hit object at another corner, and he will get more tiny fragments here, and only in this case, player will understand that demolition happens right in front of him. There is nothing predefined, nothing prepared by you, and only player defines how object will be demolished. So this is where you should use contact bias property. Next property I want to show you is this depth fate, and it defines amount of fragments, this amount property for secondary demolition. And you can see this property only if you have depth more than 1 or if you have it at 0. which means that there'll be another demolitions. And right now I have the amount set to 50, so I want to demolish my object to 50 fragments. And depth weight set to 0.1. It means that this value will be multiplied by this one, we will get 5, and every fragment will get its amount set to 5 fragments. So here are my fragments, and you can see demolition depth set to 1 out of 2, so every fragment can be demolished further right now, but its amount set to 5. So with this depth weight property, you can define how many fragments will generate every secondary fragment after secondary demolition. So now you can see almost every fragment was demolished to 5 fragments. And in this case, I have set depth weight to 0.5, which means that every fragment will get 25 amount property for every created fragment. And obviously in this case, you'll get much more fragments. You can see a lot of very small fragments. Some of them do not demolish because of the demolition time quota. This is the property from Rayfire Manager. I will show you how to use it in other tutorials. And in this example, I'm using multiplier 1, the weight set to 1, which means that every fragment also will be able to be demolished to another 50 fragments. As you can see, some of the fragments wasn't demolished again because of the demolition time quota. But as you can see, you can create a lot of fragments just by decreasing or increasing this one, the fade property. Next property here is clusters, and just like in Shatter component, it allows you to glue fragments together into more complicated concave shapes. So here I have 3 examples. For this one, it's set to 0, which means it's disabled. You can also use value 1. In this example, I have set it to 2, and for this one, it's 5. Now let's start simulation. So here you can see fragments from the first one, clusters disabled. You can see it creates this perfect convex fragments which are very physics friendly. There will not be any explosive simulation with such fragments. Everything will be simulated right. In this example, I have 2 clusters. And here you can see it created this one cluster, and here's another one. And if you will select fragments here, since I used the same seed, this object also was fragmented to the same fragments, but in this case they were glued together. So we can select these fragments here. Here you can see that this curve perfectly matches this one. So in this case I have all fragments separated. In this case they were glued into one concave complex shape, and the same for bottom one. But also you can see that the problem with such clusters is that when you simulate them, they use this mesh collider and they create this convex shape for colliders, these green lines. And the same for this one. And as you can see at this area, at the middle, you can see they share the same space. So when I will click next frame, they will instantly push each other from the shared space. And this is why you may get explosive simulation if you use a lot of clusters. All of them will just explode right after they will be simulated together, like in this frame. Here you can see they instantly pushed each other from this shared space. A bit later I'll show you how to fix this. And in this example, here you can see it created 5 clusters. And again, at the next frame, they will push each other out of the shared space. Here, right, instantly they pushing each other, and then they start simulating. So as you can see, using clusters, you can create much more real shapes. Instead of these simple convex shapes, you can get much more complicated, interesting shapes. And if you want to avoid this explosive simulation, you can go to physics enable here ignore near property. In this case, you won't get explosive simulation, but all colliders that overlap with each other at the beginning, they will simply ignore each other. You can see they completely ignore each other. They cannot collide, but in some cases it might be good enough for you. And in this example also you can see they overlap with each other. Okay, only this one still interact with this one. This is because when they were created, they didn't overlap with each other. So with ignore near, they only ignore fragments which overlap them when they were created. So this is how clustered works. Next property is seed, and seed defines how points will be distributed in the point cloud, which will be used for fragmentation. So with same seed, you always will get the same point cloud distribution. So you'll get always the same fragments. With zero seed, you will get a random point cloud distribution every time. So here you can see my example. For this two, I set it to 1. For this two, I set them to 0. And let me set maybe lower amount of fragments so it will be easier to see. You can see it created these fragments. In this case, with the same seed, I'm getting absolutely the same fragments here and here. This one and this one, this one and this one. And in this case, I used value 0. And as you can see, I'm getting different fragments all the time. So I can maybe try again. And again, you can see I'm getting absolutely the same fragments which I got from in the previous example. And this time I have completely different fragments here. So this is how seed works. Also, seed affects cluster point cloud distribution as well. So with different seed, you will get completely different clusters as well. So this is how seed property works. So default fragmentation type for rigid component is Voronoi. It demolishes subject to Voronoi fragments, and all you can tweak here is only amount of fragments, contact bias, cluster seed, and basically that's all. That's what you get, just a regular Voronoi shapes. But if you want to use other fragmentation types, as you can see in Rayfire Shatter, there are much more fragmentation types. In this case, you can add Rayfire Shatter component in addition to Rayfire Rigid component and enable this use Shatter property here. As you can see right now, it's disabled, so you can tweak default demolition properties. And if you enable it, it will hide all these properties because you don't need them anymore. Instead, you will need to tweak properties in Rayfire Shatter component. So when you are happy with your setup, basically all you need to do is just start play mode and initialize your object. Okay, now you see you got all these splinters which you prepared using Shatter component. In this case, I have used Shatter enabled, and I'm using Shatter component with radial fragmentation type. As you can see, by default, it puts center of this radial fragmentation type as the center of this object. I can use this set center feature to put center whenever I want. But when I use this with Rayfire Rigid component, it will put center at the collision or at the impact point. Let's say you want to shoot your glass object using gun. So again, you can tweak your setup as much as you want and just disable interactive mode. Use Shatter enabled. Rayfire Shatter is ready. Initialize. And this time, as you can see, it put center of the radial fragmentation type at the collision here. In the same way, you can shoot your glass object at any point and using Rayfire gun component. I will show you this later. And radial center of the radial fragmentation type will be at this impact point. So this is how use Shatter property works. And one more reason to use Shatter component here is that sometimes you may have object with outer surface and they'll have this inner surface. As you can see, outer surface and inner surface, and these two surfaces, they are not connected with each other. So by default, Rayfire Rigid component, when demolishes such object, it separates all not connected surfaces and fragment every surface separately. So when it will demolish your outer surface, it will have no idea about inner surface, because in this way, object demolishes much faster. So this is what you will get if you will demolish such object just with rigid component. See, I demolished it. Here you can see it fills all this inner surface because it don't know about inner surface and that there should be some space inside. But in this case, I'm using Rayfire Rigid component. I'm using it with Shatter component. And the Shatter component provides much more properties here for fragmentation. And the property we have to have disabled here is separate elements. Again, I can show you with separate elements. It creates fragments like in previous example, but when you disable it, it fragments both surfaces together, and only in this case it can fragment it right. So if you want to demolish such object, you need to use Rayfire Shatter. In addition to Rayfire Rigid component, use Shatter and disable separate elements. Object will be demolished the right way. So this is another reason why you should use Shatter component in addition to Rigid. So next property here is this children property, and let's say you have one object which you want to demolish, some big object which you want to fragment and simulate its fragments, but then there are a lot of very small objects which you don't want to fragment and demolish because it will take a lot of time to fragment them all. You just want them to simulate as is, as fragments after demolition, and until demolition you want them to be a part of original object. So in this case, I have this cube, which is going to be demolished, and then I have this 4 little small cubes as children. So just a really simple example, just to show you how this property works. And so in this case, add children is disabled. And as you can see, when this property is disabled, all children simply deactivate with original object. As you can see, right now I have this root with fragments. And the original object which was demolished, it's here. In its properties, reset properties here, it says destroy with delay 1 second. So in a second after demolition, the subject will be destroyed. So you have enough time to get some information about the subject in your code if you need. But after a second, the subject and all its children will be destroyed. Okay, and in this case, I have this property enabled. And right now you can see original object demolishes and it adds all these children into the list of fragments. Here, this root with all its fragments, and make all these children part of the simulation and just as regular fragments. So this is how our children property works. So next property here is Frag Sim Type, and by default it's set here to dynamic simulation type. So it means you can start your object with any simulation type, but when it will be demolished, it will turn all fragments into dynamic, because in most of the cases, this is the simulation type you may want for your demolished fragments. So this is the default behavior. As you can see, I started as kinematic, so I can drop something not so heavy, and it will interact with this bridge. But if I will drop something from the bigger height, it will demolish object and turn all fragments to dynamic object, because I have set here Frag Sim Type dynamic. And in this example, I set it to inactive. So again, I start as kinematic object. Just like in previous example, it will interact with other dynamic object. But when something big will hit it, it will be turned into inactive. And this time you'll get this kind of simulation, because this fragment's right now inactive. And as you can see, some of the fragments are activated because Here in activation, I've set to 0.1, and when this object demolishes the fragments, all these fragments, they also get the same properties, just like the original object. Right now they are inactive, and they can be activated by offset. And this is what happens when this rock continue pushing them. In this way, you can demolish your object and turn fragments into any simulation type you want. Depends on what you want to create. So this is how Fragment Sim Type properly work. And while we are talking about fragment simulation type, this is how you can use unyielding components to apply different simulation types for fragments. In this case, I have this bridge. It starts as an active, and after demolition, I want fragments to be dynamic. This is how it works by default. So you can see I demolished it. All fragments right now turn to dynamic and they fall down. In this case, I also started as an active, and again, all my fragments sim type is set here to be dynamic. I don't have any rock which will demolish and push fragments like in previous example, but this time I'm using this to Rayfire Unyielding component, and they allow you to use this gizmo to define area which you want for fragments to have different simulation type. So in this case, as you can see, I set here simulation type kinematic for both of these unyielding components. And so I applied them to original object which I want to demolish, just one this bridge. And this is how fragments will look like. So here you can see only fragments which were not overlapped by unyielding gizmo turned to dynamic, while these fragments which were overlapped by unyielding gizmo, they turn to kinematic simulation type. So in this way, using unyielding components, you can define areas of your mesh object which will get this simulation type from the unyielding component, while other fragments will get simulation type by this fragment sim type property. So next property here is runtime caching, and by default it's disabled, which means that all fragments will be cached in one frame when demolition will be initiated. But using runtime caching, you can cache every frame by a few fragments. There are two ways to do this. You can define exact amount of frames which you want to use, or you can define the amount of fragments per frame which you want to generate. So in this case, this runtime caching is disabled, and I have set here 300 points, and which is a pretty big value for runtime demolition. And notice huge FPS drop when this object will be demolished. So as I noticed, there was pretty big lag when rock collided with column. So in this case, I enabled runtime caching for this column, and I set it to by 5 fragments per frame. So this time, now you see that there wasn't such FPS drop like in previous example. I'll show you again. Here you can see it will collide. I'll select column here. Here it collided. And here you can see in this info section, right now it says runtime caching is in progress. So for next few frames, rock continue simulates. My column is still solid, but it says here runtime caching in progress. And after a few seconds, all fragments cached, and only after that, this fragments was demolished. One more time. So in some cases, it might be okay for you. You can delay demolition for 3, 4, 5, 10 frames and no one will notice. But if you want to use like really huge amount of fragments and you don't want the user to see this huge delay in demolition, then you can use this skip first toggle. So in this case, I have enabled the skip first, and again I will set it. Let me be same 5 fragments per frame. So this time I will initiate demolition, using this first rock. So just like before, it will collide with this column. Okay, now you see it says runtime caching is in progress. So for next 2 frames, rock will continue simulation and column will cache every 5 fragments per frame. But after all fragments will be cached, it says here fragment mesh is cached, but it not demolished this time because it's waiting for second demolition because skip first is enabled. So right now all fragments cached, but this object will now wait for second demolition initiation. So to do this, I will use this rock. And as you can see, this time, after second demolition, object was finally demolished. So using this skip first toggle, you can initiate demolition in advance using demolish method in your code. So if you know that some object will be demolished and you want to create a lot of fragments for this object, you can start demolition caching with runtime caching set to by fragments per frame or by frames and enable skip first toggle. And then after a few seconds, all fragments will be cached, and then finally you can hit it with something like, so this time I'll show you this. Like in this case, you can just use demolish button in this case because I'm using editor, but you can do this in your code. You can just call demolish method. Object caches all the fragments. And when all fragments cached, you finally can hit it with object which is actually should demolish object to a lot of fragments. So this is how runtime caching property works. So next property here is convert, and by default it's disabled. So using this property, you can convert your demolished fragments into connected structures. For this second example, I'm using connected cluster, and for this one, I'm using connectivity property. So first, I will show you how it works by default. So when you demolish your object, you just get this bunch of fragments. Here is the root with all the fragments. As you can see, this root is just has only transform component. Every fragment has its own rigid component with mesh object type. And every fragment simulates separately. There are no any connections right now. But with this example, I will turn my fragments into connected cluster after demolition. So you can see it collided with my original mesh. It was fragmented to these fragments, but then it was turned into one connected cluster, and instantly this connected cluster was demolished by the same collision. So now you can see I have this bottom part of the connected cluster. Right now, this is just one simulated object. As you can see, it has its own rigid body. All the fragments, they only have this mesh collider. So right now, it simulates this bottom part as one object. And there are all this bunch of fragments here, which were detached to be simulated separately. They have rigid component with mesh object type. So this part simulates separately. And also there's this one little connected cluster as well. This is how the simulation looks like. You can see that the part which collided with this rock, it simulates as separate fragments. And then there is one big connected cluster at the bottom. I can push it and it will be simulated as one object. I can break it. You can see it continue breaking. You can continue demolishing it by collision or in some other way. So in this way, you can create more complicated demolitions. And in this third example, I'm using connectivity. So in this case, it will use connectivity with unyielding component. There will be another big tutorial about how to use connectivity with Rayfire unyielding component and mesh root object type. In this one, I will just quickly show you how it works. Let me demolish my object. Also, I want to mention that, as you can see, you need to apply Rayfire connectivity to actual mesh which you want to demolish, and Rayfire unyielding to define this area at the bottom. You can see by this blue gizmo, I define some fragments at the bottom. So when object will be demolished to fragments, connectivity will establish connections among all the fragments. And then later, when I will start simulate them, if some fragments will not be able to check for connection through other fragments with these unyielding fragments, they will understand that they should be activated and turned into dynamic. So right now you can see I have here, I start simulation as dynamic, but after demolition, I turn them into inactive fragments. Only in this case, you can use connectivity only with inactive and kinematic simulation types. So as I said, there will be special tutorial. For now, just show you how this can be used, how this property works. Okay, you can see now it demolishes these fragments, this object to fragments. In this case, every fragment simulates separately. You can see every fragment has its own rigid component. Also, there are these green lines. They show you connections among fragments. And fragments at the bottom here, they have these red lines, so they show you unyielding fragments. If you'll select these fragments and go to Rayfire Rigid component, in activation, you'll see that they have this unyielding property enabled, while this don't have unyielding property enabled. So now I will drop another rock. You can see this rock pushes these fragments, and because in activation property they have this offset property enabled, when these fragments move too far from their initial position, they activate and turn into dynamic. You can see here it says inactive. If I will move it too far, it turns to dynamic. So in this way you can push your object and they will turn to dynamic. And now I'll show you how you can activate fragments which are not connected with bottom. So I'm pushing these fragments and you can see this upper part turns into one connected cluster, because in my connectivity component here, I have this clusterize property enabled. Again, as I said, I will show you how to use all these properties in special connectivity component video tutorial, because there are a lot of properties and it will take a lot of time to show all of them. For now, just a quick overview of how this convert property works and what you can do with this property. So next property here is collider, and it allows you to define collider for your fragments. Default one is mesh, and it provides pretty nice simulation results, especially for Voronoi fragments. As you can see, no explosive simulation. Everything looks nice. Every fragment gets this convex shape, which wraps it. But this is the most resourceful collider type, obviously. In this case, I set collider to box, and I will click pause here. If I will pick now, you can see all fragments get this box-shaped colliders, and as you can see, all of them overlap with each other. And because of this, at the very next frame, they will try to push each other from their shared space, and you will get this. So if you want to explode your object, it might be okay for you. But if you want to avoid this, then you can use ignore near property, as in this case. I'll set here also box, but this time I will enable here ignore near property. You can see again all colliders overlap with each other, but this time all colliders that overlap with each other, they will ignore each other and they will interact only with colliders that they are not overlapping right now. It looks much better than this second case. So this might be enough in case you want to demolish something on the background and you don't care much about collision and how it will looks like. Also, you can use this sphere collider type, but in this case, obviously all the fragments start rolling. So maybe in some cases you need something like this. And the last one is none. In this case, fragments completely will not get any collider. They will just infinitely fall down. So that might be useful in case you want to explode something on the background and then quickly fade all the fragments and destroy them. You do not care much about collisions, and there's no reason to spend resources to this collision, so you can just pick here none, and then there will be no any colliders on fragments. So next property here is this input cap property, and it allows you to automatically close volume for all meshes with open edges and open volume. And I am calling meshes with open edges and open volume this kind of objects. As you can see, this one, it has this outer surface, but it has no inner surface, and then there's this open edge here. So obviously this kind of object cannot exist in the real world. And if you will try to demolish this kind of object with disabled input cap, it will only cut surface, just like in this example. You can see it created these fragments, but these fragments, they do not have inner surface. It just cut surface and then create fragments based on these cuts. And in this case, I have enabled input cap. So first it will create surface for these open edges here. So volume of this mesh will be closed, and then it will fragment it to 3D fragments. Here you can see now it closed volume and then fragmented the subject as a real world object. Next property I want to show you is combine property, and it allows you to combine parts of different not collected elements into one fragment. So let me show you. So let's say you have one mesh. As you can see, this door is just one object with one mesh, and this mesh contains a lot of very small elements not connected to the main body by topology anyhow. If your combine property is disabled, this is what you will get. And as you can see, I've set here amount of points in point cloud to 30. But if I will demolish this kind of object with disabled combine property, you can see that every bolt right now is separated game object. And I'm getting much more fragments because 30, which I'm used as amount of points in point cloud. This is just the points in point cloud, but then they used to slice every not connected separated mesh element. And since there are a lot of these bolts, all of them returns as a separated game object. And in this case, I have combined property enabled. And in this case, I will get exactly what I asked. So 30 fragment, and all these bolts are part of this fragment. So just keep this in mind. If you have mesh with a lot of small elements and they are not connected anyhow, then you should use combine enabled, because otherwise every such small element will be a separated fragment, and with combine enabled, they will be part of the fragment. And last properties here are inherit layer and inherit tag. And it simply allows you to set custom layer or custom tag for the fragments. So by default, all fragments inherit layer and tag from the original object. So in this case, you can see I don't have any tag on my object. Let me set some tag here, like say player and maybe like water. And when I will demolish my object, every fragment also get the same tag, the same layer. In this case, I set here I disabled inherit tag, and in this case I can set here my layer for my fragments. And for this one, I'm using inherit tag. I set finish tag for fragments. And as you can see, I'm getting this water layer for these fragments and finish tag, finish tag for these fragments.